Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at Starling-7B. It's an open source large language model was trained by reinforcement learning from AI feedback and RLAIF. You would have seen or heard about RLHF, after the rise of Chat GPT like last year, and now there have been some novel architectures like RLAIF where the human feedback has been replaced by AI feedback. And this is what Starling 7B is all about. It's a team at Berkeley, they have announced this LLM, and it's a very cutting edge approach, right? From AI feedback. That's what we're going to look at in this video. Now, this method uses feedback from another AI model, like for example GPT-4, to improve the chatbot's performance. So if you look at this here on the screen, it's a website by Berkeley. You can see it's ch.berkeley.edu, and where they talk about an intro, the way they have trained it, how what kind of evaluations that they have performed. Now, Starling 7B signs in empty bench with an evaluation benchmark criteria, scoring more than 8 in empty bench, where GPT-4 was a judge, and they have outperformed every model to date on empty bench except the OpenAI GPT-4 family models. Now, Gemini is something that we need to check that, but only the GPT-4 family is something that Starling could not surpass, but it has outperformed all the other models. Now, it's not only about on like talking about this LLM, but they have also released several resources to help the community explore RLAIF, and one being something called Nectar. So Nectar is a ranking dataset. As you can see, it's a high quality dataset, of different or several chat prompts with GPT-4 labels and for evaluating chatbot performances. Now, Nectar is extremely powerful. It's really going to be helpful for RLAIF kind of an experimentation. They have released a couple of other things. One is RM7B Alpha, which is a reward model used to train the LLM itself. And this LM7B Alpha that you see here on Hugging Face as well, it's a language model that you're gonna use today for inference and all. They have also come up with a Gradio kind of an demo that has been available on LM6 chatbot arena, right? Which also look at the Elo rating and all. You can find it over here. Now, let's try it out and see the inferencing part of it. You can see it says supervised fine tuning as demonstrated, blah, blah, blah. They're talking about the alpacas of the world and how RLHF and now the RLAF can enhance models when scaling high quality preference data. Now, these are the information that you find here. You can read more about this here. Now, let's come back here on Colab. You can see I am on Colab notebook. I'm going to install a few of the libraries like transformers and accelerate. So let's do that. So pip install transformers and accelerate. I'm on a Colab Pro, and I'm using V100 high RAM GPU. You can also use T4 as well, because nowadays Colab don't give you A100 and it's not easily available. Yeah, but you can also use that. Now the next thing is from transformers. Let's do that. Import auto tokenizer. So let me just do auto tokenizer. And I don't need auto model for sequence, but I need auto model for causal. So let me just do that, because it's a text generation task that we're gonna perform. So import torch. Now this will help me get the libraries. Now let's have our tokenizer. So tokenizer equals, auto tokenizer dot from pre-trained. Generative AI is now integrated within Colab. So you see all these auto suggestions, but we don't need Dilo GPT by Microsoft, which is helpful to build conversational chatbots. Uh, you have Starling LM7B Alpha of the tokenizer we are getting. The model will make a couple of changes here. Let me just do that quickly. Okay, so this is fine. And after that, probably uh, we need the data type. So torch D type, and let's have float 16. So torch uh, d type equals torch dot float and 16. That is right. 16. That is right. Okay. Let's have the device map auto. So I'm just gonna have device map auto. Let it figure out the CUDA as well. I think we are fine here. So let me just do that. And you can see it gets the tokenizer, the model. It will have basically three sharded model weights that you see. It's the safe tensors, the right way of saving the models nowadays. When you compare that with .bin, etc. This is better. Now it will take a bit of time, but let's write our text generation function. So let me just add a couple of code here and make it more of a text. Okay, so we don't need that. Let me just do a double click and do a bit of documentation kind of a thing. Text gen function. Let's write a text generation function here. Now, in that, I'm gonna do def generate, and you can see the model has been almost downloaded. Once it downloaded, we need to load the model. It will automatically be loaded. Now, generate response prompt. You can see it's now loading the model. It says loading checkpoint starts. Okay. To generate response prompt, what I'm going to do is input IDS. Now let's do that. Okay, input IDS equals tokenizer prompt. This is right. So we need to tokenize the prompt, and then it will return a PyTorch tensor with all the IDs, right? The respective IDs for the tensors. Now, input ID is correct. Now let's have an output thingy here. So output equals, I'm going to use generate method. This is right. Now let's see what's it doing in generate. It's saying model or generate input IDS, but I don't need that. I have to bind that with device. So let's do input IDS dot to and model or device. Okay, this is what I'm going to do here. Model or device. Max length. There is nothing called max length for this model. It should be max new tokens. So let's do that. Now max new tokens equals, let's keep it example 1024 or something. Where is the temperature? So let's define a temperature. These are the inference parameters that we're going to define here. So temperature equals 0. Let's keep 3. 0.3 is fine. And then do samples true. Let's remove the top k thingy from here. Let's have what do we need? We need the pad token ID and the end of EOS token ID as well. So we can use that through tokenizer. So I think pad token ID equals token, excuse me, tokenizer dot pad token ID, and then we have EOS token ID. So let's do that. Now EOS token ID equals tokenizer dot EOS token ID. That is fine. Okay, now this return, let me see the return thingy here. Return tokenizer, we need to, let's don't do a batch decode. We're not doing that. Let's do a decode thing, which is output, and I'll just remove this. We don't need it. Then we have the outputs. I don't need to skip special tokens for here. What I need is the size of the input IDS. How should we get that? It's the list. So input, I think, dot size, and then you pass here as this to do. Now this is a function that I've written. It says invalid syntax. What's okay? There should not be a comma here. My bad. Okay. Now return tokenizer dot decode. Now once you are done with this, right, the next thing which is important to understand, let me just add a couple of things here. Okay, the next thing is to add a let me just do a prompt kind of a format, right? So prompt format, it's so basically it uses an open chat format. Let me just write it over here if you need to find out open chat format. And this is how you do it basically. Let me just show you. So GPT-4 something like correct user or whatever, GPT-4 user, and then you pass your prompt as a variable. So prompt, and then you have your end of turn, etc. It's a pipe. It's my bad. Okay. End of turn, and then you do GPT-4 assistant or something like that. Okay, this is how the open chat looks like. Right now, let's do a single turn conversation, and then we'll move to the multi-turn conversation. We can do both. We're having some follow-up questions as well. Now, what I'm going to do is write a prompt here and say, what is AI? Okay, let's ask this question first. Okay, now this is my prompt, and I'm going to define a single turn prompt here, and then in single turn prompt, I'm going to use probably the same thing that I have defined here. Let me just copy it from here and paste here. Now let's see what it's doing. GPT-4 correct user, and then you have prompt thingy, and then you have your end of turn GPT-4 correct assistant. This looks nice, right? So this is your single turn prompt that you basically have defined. Now let's have a response variable kind of a stuff. So response text equals generate response, and then you pass single turn prompt. Hmm. Now, this will probably take a bit of time. It depends on the compute. But I'm gonna write here print thingy, print. Let me just write response, and response here equals or something like that. Okay, and then let me just write a response text. Okay, now response text, and once it is done, we'll just print this, and we'll see what we get from this one. All right, you see it has ran successfully. Now, once we are doing print response or response text, you can see response. It says AI or artificial intelligence refers to the development of computer systems or software, that can perform tasks that typically require human intelligence, which is right. This include task as a learning, it's blah blah blah, and then you have your end of turn, right? This is a single turn prompt. And what if you want to do a multi-turn thingy as well, right? In that case, let's do that as well. So what I'm going to do next is I'm going to call it multi-turn prompt. So let me just do a multi-turn prompt, okay, here. And in this, now, um, you can see, basically, let me first define a prompt. So we have what is AI. Let's have the same prompt for this as well. What is AI? And then I'm going to ask about something, a follow-up prompt. So my follow-up question can be, so let's do a follow-up cues, and this is going to be, what are the uh, pros and cons of AI? Okay, this is my question, the follow-up question. Uh, uh, let's have a response for the AI thingy. I can give a simple response. So let me just do this, copy it here at least up to this. I wanted to keep a larger one, so this is fine, which is your response thingy. And once you do a response, then you have to define a multi-turn prompt. So multi-turn prompt, and how do we do that? So uh, let's first copy it, at least this one, and then we'll add here. So let me just bring it this here. GPT-4 correct user, then you pass your prompt, the end of turn, then the GPT-4 correct assistant, and then let's, for example, have the response here. So let me just do a response thingy, response, and then again, you do response, then you pipe end of turn, and then you do GPT-4 correct user again, and then you pass your GPT-4 correct user, then follow-up questions, end of turn, GPT-4 correct assistant. This is fine. This is right. Now let me just run this. It might be overwhelming to write everything in a same cell. Now multi-turn response. Let's see if it's able to derive some responses from the previous one. Now, generate response, multi-turn prompt, multi-turn. Let me just run this. Now multi-turn response, generate response, and we have passed this prompt. Now let me just print that as well here. It will take a bit of time to do that. Let me write multi-turn conversation. So it's an AI feedback, guys, right? We're not relying on a human feedback in Starling-7B. So the response, and I'm gonna write excuse me, multi-turn prompt, multi-turn prompt. Now this should, let's see what kind of response we are getting here. Okay, let's do that. And after that, we'll also try it out with some coding examples. Okay, one of the coding, because I want to test this out on some coding examples and see if it's able to infer it or not. So we'll do that after this. Let's wait for that. So coding also have a similar way of open chat prompt, but let's wait for this and see what we get for this one. The thing is, even on V100, you can look at here. I have a V100 high RAM. It takes a bit of time. It took more than 1 minute for this one, which I feel is not, which is not that scalable at this moment. Because we'll have compute limitations if you want to deploy this. But let's see what we get. It says multi-turn conversation report, GPT correct a response, GPT for correct user. What is AI? And it says AI or artificial intelligence refers to the development of computer systems or software that can perform tasks that typically require human intelligence, and then correct who are. And you see, that's funny. Okay, I didn't get what I was expecting here. This is surprising because uh, okay, I have passed multi-turn prompt. So bad. It should be multi-turn response. This is my bad. Okay. This is so bad of that. Okay, I just printed the prompt, and I was saying it's not working good, but you can look at here, right? Fantastic. I mean, I love this. A multi-turn conversation response, the pros of AI and the cons of AI, the job displacement, the ethical concerns, the high initial cost, right? So it's a costly technology altogether, dependency on tech, a lack of creativity. And if you look at the pros of AI, improved efficiency from a productivity standpoint, and you can see it says AI can process and analyze large amounts of data quickly and accurately. I think that is fine. Cost savings can help you automate repetitive tasks or the redundant task, etc. Right? It helps you save the cost, enhance customer experience through some chatbots, the digital humans of the world, etc. Improving the decision making can help you analyze complex data sets, some patterns, and derive responses which is difficult for a human being to infer. Now, early detection of anomalies, AI can be used. Fantastic. I mean, I loved it, to be honest. Now, let's try it out on a coding problem because I'm more interested in that. Now, for the coding one, the prompt that you have to define is a bit of different, but very similar, but a bit of difference is there. Let's write a prompt first. What I'm going to do is create a fast API. Or let me just write a fast API, not a create. Write a fast API code to uh, develop a REST API or something like that. Very simple. Let's see what it gets. Okay, it's able to understand the fast API taxonomies or not. Now the coding prompt, how do we do that? So coding prompt equals in the coding prompt, this is how you do. So in coding, you have to write code user. This is how the structure looks like based on the paper that they have. Now the code user, and then I'm gonna pass you a prompt again. So prompt and end of term. Excuse me, my bad. Prompt, and then you define your pipe thingy. End of turn code assistant. Fantastic. This is how you define the coding prompt. Okay. Now it takes your prompt, and let me just do a code prompt or something like that, because I don't want to use a notebook later on. I don't want to confuse. Okay, coding prompt. I don't want to override the variables basically. Okay, now the response code equals, you're going to use generate response, then pass the coding prompt. Now let's see what it does for that. And after that, let's print that and see what it does. Now here also you can do a follow-up, okay, with the code thingy as well. Now let me just do a coding conversation kind of a thing. Coding conversation response, and then you do response code. Okay, now let's see that what we get here for this part. And Yeah, I mean, you can also use, guys. I wanted to tell you that, if you don't want to use this in Colab Notebook or if you want to use it for some kind of RAG implementation, right? Starling LM7B Alpha. You can also look at the block repository on the Hugging Face. Let's see that. So I'm going to write the block and it says no result found. I don't know why. Okay, let me just go to block. I'll come to block and look at his model. He has more than 2000 model, which is crazy. The generative AI, he has a huge role to play, in that. Let me see if I can search something like Starling, if there is anything. I believe there should be a GGUF version of Starling, and you can find it out over here. Now, if you want to use on a compute limited hardware, you have a single GPU kind of stuff. You can come here on this repository and you can download a GGUF file and you can find out maybe the KM is the recommended way, the 4-bit quantized medium GGUF version, which is around 4.3 GB. That helps you inference on CPU as well. So you can use this through Llama CPP or the Python Llama CPP or the Llama CPP Python, by the way, and then the C transformers of the world, right? You can use that to inference it on a CPU machine, and you can use it in the RAG as well, this model, if you want to use it. Now, let's see for coding how it does. Now, what it does here, guys, it says from fast API import fast API. This is right. So it gives you a very simple endpoint, which is this root hello world, which is right. This function is correct. A very simple function, which is right. In this code, we import the fast API class from the fast API library, an instance of the fast API class called app, which is correct. And it also tells you about UVCon. Fantastic. I mean, the file name is main.py. Then you run like this. Okay. I loved it. Wow. And it also gives you a complete explanation of how to run this, on a localhost 8000, which is the default port for fast API apps using UVCon. This is great. I mean, I love Starling. I love to use this in some of the RAG application that I'm gonna have been building. Maybe let me know your thoughts or the feedbacks on the Starling LM Starling LM7B Alpha. This notebook will be available on my GitHub repository. I'll give the link in description. I'll also give the link of this Berkeley website for the Starling 7B. I hope you learn something with the Starling. It's a very new. Every week we are seeing a new LLM that is like surpassing the rest of the LLMs. It's difficult to keep a track of it. But this is important, guys. To look at some novel architecture that helps you to build better systems with generative AI and the large language models in general. So I think that's all. If you like the video, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe the channel. And if you have any thoughts, feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. That's all for this video, guys. Thank you so much for watching. See you in the next one.